Okay, so now we want to take a quick look at the speed of light. We said before that the speed of light is equal to 3 times 10 to the 8 meters per second. This is true of all electromagnetic radiation in a vacuum, but where does it come from? Well, it turns out that if you take 1 and divide it by the square root of epsilon naught, or a vacuum permittivity, times the permeability, so mu naught, if you do that, you get exactly the speed of light. So remember, epsilon naught is related to how electric fields can permeate a vacuum, and the permeability is mu naught, and it tells us how much a magnetic field can permeate into a vacuum. So these are connected to how easily an electric and a magnetic field can move through space. Since electromagnetic radiation is caused by electric and magnetic fields inducing each other and propagating, it makes sense that these concepts are connected. Okay, so now we want to find the energy density of electromagnetic radiation. So the energy density is this little u. So we have u sub E for the energy density of the electric field, and the u sub B for the energy density of the magnetic field. So the energy density, this little u, is a measure of the energy per volume. So it's the energy density. So the question is, how much energy is carried by the electric field in an EM wave? And there it's equal to 1/2 epsilon naught, our permeability, times the electric field of the electromagnetic wave squared. The energy density carried by a magnetic field of electromagnetic radiation is the magnetic field squared divided by 2 and divided by mu naught, the permeability. So it turns out the energy density of a magnetic field is half the energy density of the electromagnetic wave, and the energy density of the electric field is half the total energy density of the wave. So basically, you add them up together to get the total energy density of the wave. So you remember from the last slide, the speed of light is equal to 1 over the square root of mu naught epsilon naught, and the mu naught times epsilon naught is 1 over the speed of light squared. So we can rearrange this to find the electric field is equal to the speed of light times the magnetic field in electromagnetic radiation. So if we know the electric field, we can divide by c to get the magnetic field strength, and if we know the magnetic field, we can multiply by c to get the electric field. Okay, and then we've got some other things here. The point of this is that exactly half of your energy is in the electric field and half is in the magnetic field. So it turns out if you just multiply each term by 2, then you get the total energy density. So epsilon naught E squared is the total energy density of an electromagnetic wave, and B squared over mu naught is also the total energy density. Since they're connected, they can both be the same. Okay. So now we want to find the relationship between the intensity of electromagnetic radiation versus the energy density, so our lowercase u. So if we want to know the intensity, we take the power of the light and we divide it by the area over which it's shining. If we want to know the energy density, we will take our flashlight here that is shining on a surface, and we want to know the intensity of the light on the surface. So next we want to know the energy in this beam of light. So we take the energy density times the volume of this beam of light. The volume will be the area of the beam of light times the distance, which is the speed of light times time, right? So distance times velocity is equal to time, so the speed is the speed of light. We can rearrange this and get the energy per unit time, which is power. So U divided by delta T is the power. That divided by the area, so power divided by area is intensity, and that is equal to the energy density times the speed of light. So that means that the intensity of a beam of light is equal to the energy density times the speed of light. So if we have the intensity, divide by c, and we have the energy density, we can multiply by c to get the intensity. Okay, so we want to try a problem here. So in this case, we have an electromagnetic wave that has an electric field strength of 0.1 volts per meter, and we want to find the magnetic field strength. So the electric field is equal to C times B. So If we do this, we divide both sides by c to get the magnetic field is equal to the electric field divided by c. And now we plug in our values. So the electric field is 0.1 volts per meter. We divide by 3 times 10 to the 8, and that gets us our magnetic field strength being 3.34 times 10 to the minus 10 Tesla. So remember, if we have the electric field, we can find the magnetic field. We have magnetic field, we can find the electric field. Also, remember, the intensity is equal to the energy density multiplied by C. So if you have the intensity, you can find the energy density, or vice versa. Okay, so you have a couple problems to do here, so good luck with that. And next we'll look at the polarization of light.